and makefile projects on a Unix or Linux-based server. In this example, we're going to be looking at the ece3 server at the University of Arizona. So first I need to log on to that server. And for my Mac, I can run a tool called ece3. If you're on a Windows machine, you can use programs such as a secure client shell or a program called PuTTY. So I'm going to SSH using my ID on that machine and the address of that computer, which in our case is ece3.ece.arizona.edu. So in here I'm at my home directory, which is located at home/home/r/lyseki, and I've created a directory where I've set up this demo. So inside the CMake directory here, we can look at the example that we're going to look at. In this case, we have a folder called graph, and inside graph is where we're going to do our commands. So inside here we have our first CMake list.txt file, and we can examine this CMake list.txt file by running the less command. In our example here, we can look at the commands. So the first command we see here is setting up a minimum requirement for CMake to make sure the commands we use are compatible with the version installed here. We then define a project called graph project. And additionally, we run a command that is add subdirectory. Add subdirectory tells CMake to look into the src directory for further instructions. Let's take a look at inside that directory. So inside here we'll see a second CMake list.txt file. If we take a look at this CMake list.txt file, the first command we'll notice in there is a command to set the C compilation flags. -w all informs it to enable all warnings during the compilation, and -g tells it to use a debugger. The second command will search for all .c and .h files located within the current directory, and it's going to add those C and .h files to an executable named graph. So what we've defined with our CMake list files is we've defined a project called graph project, and we've defined an executable called graph. And that executable.graph is dependent upon all of the .c or .h files located inside the src directory. In our case, we only have a single file called graph.c that will be added. Let's change directory back to the previous directory, where now we're back at our graph directory, which was our top level implementation. So because we'd like to keep a separate folder where all of our temporary files and build files and compiled executable are located, we're going to create another directory called build. So we can run the command mkdir build. We now have a new directory called build, which we're going to cd into. Now that we're in the build directory, we'd like to run the CMake command. When you run the CMake command, we need to specify where the location of the first top-level CMake directory is. In our case, because we're in the build directory, our CMake list file is not located in this directory. Instead, it's located in the previous directory, or the directory one level up. So we can run CMake with the command CMake space ... This will tell it to look up at the previous directory for that CMake list.txt file. The CMake command will first look at the implementation of our system to make sure we have valid versions of our compilers installed, in this case GCC. It's going to test those compilers to make sure they work. When it's done, because we ran it with the default option, it's generated what's called a makefile project, or a make project for short. If we look in here, you'll see that there's a new file generated inside the build directory called the makefile. We're not going to examine the contents of that makefile, but feel free to do so on your own. The makefile tells us how to actually build our executable. For us to actually build the executable, we simply need to run the command make. Make then will run our command, and if you notice, you can see it compiling. So it compiles each of the .c files here. In this case, it compiled the file graph.c. If you had more .c files, it would keep compiling all of those. after it's compiled all your .c files, it will link them together to generate your executable called graph. So now our compilation is done. If you notice, you might see some warning messages in this case, which says, warning, modification time is in the future. This has to deal with the location of how the file system is set up. The file system for our home directory on the ece3, our home directory and our ENGR account are located on a different server than the ece3 server. So the timestamps for ece3 and the timestamps for our files can be out of sync. In this case, it's telling us that the two machines have an offset of about 260 seconds, which is a few minutes. This is okay, and it's something that you do not need to be concerned about. Now that our program is compiled, the location to run our program is we can specify ./src/graph. The dot command here tells the system to run an executable located within our current directory. src tells it to look inside the src directory relative to the current directory, and then graph is the name of that executable that we created. If we simply run it like that, you'll notice we will see a usage statement that tells us we did not execute our command correctly because it expected an additional command line option called graph file. To run it with a different file, we can simply provide on this line the file to execute. For instance, we could have a file that's located within our home directory, graph input.txt, and we could use that as our input file. You can provide both a full path starting with a slash at the front and being the full path on the system to the file, or you can do a relative path based upon the directory you're currently running this in, which in our case is the build directory. If we run this command, it would now pass this as a command line argument into our C program, and our C program could use that to open the appropriate file.